Many depictions of the Roman military machine show identical interlocking units, marching in perfectly standardized, factory-made armor. This image often owes more to modern imagination and later medieval armor concepts than to the ancient reality of a legion on the move. A more accurate picture begins with this artifact, the Coolus helmet, defined by its simple, low, and rounded bronze bowl. While it became a staple of the Roman infantry, this specific design was not an original invention of the Roman state. The presence of this helmet in the Roman kit reflects a military tradition of observing foreign technology and adopting what worked. The name Coolus is actually a modern archaeological label, taken from a site in northeastern France where a type specimen was recovered from the River Marne. The design originated with the late Latine culture of Iron Age Gaul, where it was used by Celtic warriors between 120 and 50 BCE. After fighting against warriors protected by these helmets, Rome recognized their utility in formation combat and absorbed the design into its own ranks. The transition from a Celtic bowl to a Roman standard raises a question of engineering. How did the military transform a basic Iron Age design into a tool for imperial expansion? The history of the helmet suggests a system that prioritized the practical performance of a tool over its cultural origin. The early Coolus started with a single piece of copper alloy, requiring controlled, expert hammering to achieve its final shape. Metallurgical analysis shows the rim was 4 millimeters thick to provide structural rigidity, while the crown was hammered to less than half a millimeter. This distribution kept the helmet strong where it met the head, but thin enough to keep total weight around 598 grams. Even in this basic state, the construction balanced protection against infantry endurance during long marches. As Rome's army became a permanent frontier force, armorers added specialized fittings to the base design. A widened neck guard extended protection to the back of the head during melees. A separate brow guard reinforced the front against downward crushing blows. Hinged cheek pieces protected the side of the face, cut to ensure the eyes and mouth remained unobstructed. Tubular fittings were mounted to the crown for plumes that made soldiers more visible in battle. Every addition was a compromise, aimed at increasing armor coverage while maintaining the soldier's ability to see, hear, and breathe under exertion. While the design evolved on paper, the physical reality of service is found in helmets pulled from frontier rivers like the Wall and the Thames. Surviving artifacts show significant wear, including deep gashes hammered out to keep gear in service. Many specimens were tinned, and their neck guards often carry punched ownership marks and centurial inscriptions. These marks show helmets passing through multiple owners, being repaired and modified as they moved between different units and frontier outposts. This suggests the Roman army used a patchwork of inherited gear, rather than identical brand-new equipment. Military transitions were rarely immediate. Armies didn't discard functional equipment when new designs appeared. For years, the Coolus was used alongside older Celtic-influenced designs, such as the Montefortino helmet. The features refined on the Coolus eventually served as the basis for the iconic iron imperial Gallic and Italic helmets that followed. Archaeological categories create a neat sequence, but the reality on the ground was a constant overlap of old and new technologies. In this system, a helmet's durability and immediate utility were valued above a uniform aesthetic. The Coolest helmet may look modest when compared to the heavily reinforced and decorated armor of the later Roman Empire. But its simplicity, its dense, and its numerous repairs make it a key artifact for understanding how Rome maintained its forces. Roman military success did not depend on the sudden, isolated invention of every weapon or tool they used. Instead, the evolution of the Coolus shows a capacity to observe foreign technology, adopt what worked, and systematically strengthen those designs for long-term service.